Okay, so this is section 12.4, the chi-square test of independence. So that kind of funny looking X there is actually a Greek letter, chi. It's actually spelled C-H-I, just because sometimes you might see it actually written out. So you can use the symbol or you can use the words either way. So this is going to be a way that we can take those hypotheses, the alternate hypothesis and the null hypothesis, and test whether they would be valid or not. So the table here at the right that has the male and female, exercise, no exercise, that's what's called a contingency table. This one would be a 2 by 2. And when they give these dimensions 2 by 2, it's always row by column. So this is 2 rows and then 2 columns. Now, this is not considered a column. This is not considered a row. Those are the titles. So 2 rows and 2 columns. They don't have to be symmetric like that. That just happens to be the way this one is. So this table has to do with randomly selected adults, their gender, and whether they exercise or not. So we might want to see if the variables gender and exercise are related. They could be dependent, which we are really supposed to say not independent. So maybe females are more likely to exercise than men. Or it could be that they are independent, which means that the gender doesn't matter about whether they're going to exercise regularly or not. So the chi-squared or the chi-squared test, again with the words or with the symbols, can be used to determine whether 2 variables from the sample are independent or not. The test examines the difference between the observed values. These are the ones that are going to be given to you in the table, and then expected values that we calculate. Now, you will either be calculating those by hand, not for an entire table, but you do need to be able to calculate some of those. We'll talk about that in section 12.5. Today, the calculator does all of that for us. And I'll show you some of those steps as we go along here. So the formal test of independence says that if you have a small value of chi-squared, that's going to indicate that 2 variables are independent, while a large value of chi-squared is going to indicate that the variables are not independent. Now, it's going to be a little bit more complicated than that. We're going to have a number that's going to help us determine whether the number is big or whether the number is small. And that's going to be called the critical value. So that critical value depends on the size of the contingency table, and that's going to be measured by your degrees of freedom that we looked at in section 12.3. So 1 minus the number of rows times 1 minus the number of columns. And then the significance level that's used. This is kind of how sure do you need to be about this hypothesis. So that significance level, that's the Greek letter alpha. I had to stop and make sure I was saying the right one there. That's what we're going to talk about here next. So as the chi-square gets larger, it becomes increasingly unlikely that the variables are going to be involved are independent. The significance level indicates the minimum acceptable probability that the variables are independent. So again, it's kind of how certain you need to be about this. So normally you're going to use 10%, 5%, or 1% as your significance level. We need to think about those as decimals. So that's actually going to be an alpha of 0.1, 0.05, or 0.01. Now, this table right here, this is where the calculator is getting some of these numbers from that it's going to be using. It used to be that you had to use this table on the exam. They actually gave it to you. They don't anymore. But I still wanted to kind of show you at some point where these numbers are coming from. So if you have a given significance level and you have your degrees of freedom, that's going to give you this critical value chi-squared. We're going to compare that to a chi-square that our calculator gives us or that we can compute by hand, and we'll look at how that happens tomorrow. To determine whether my number is big enough or not, or whether my number is too big, or it's okay. So, for example, at a 5% significance level, with a degree of freedom 1, so 5% significance level, degree of freedom 1, 3.84 is my cutoff. If I'm higher than that, then we would reject our hypothesis. If it's less than that, then we would accept it. If we have a 1% significance level with a degree of freedom of 7, so here's my 1% degree of freedom 7, we have 18.48, and again, it would be too great if it's greater than that value. Like I said, on the exam, you will be given those critical values. You won't have to look at the table to find it. And you'll compare it to the chi-squared that your calculator will give you here momentarily. Okay. Now, p-value. When you're finding that chi-squared on your calculator, you also get a p-value. This is used along with the chi-squared value and your critical value to determine whether or not you accept that the variables are independent. For your contingency table, the p-value is the probability that you're obtaining those observed values as far or further from the expected values, assuming that those variables are independent. The p-value is going to tell you if your test results are significant or not. Essentially, the p-value, it is a probability, and we're going to compare that to that significance level, to the how comfortable we are going to feel about these results. And we'll see if those are high or low there. Okay, so for our actual test, we're going to, first of all, figure out what our hypotheses would be. So talked about this in the previous section. Your null hypothesis, or your H sub 0, that's going to state that the data sets are independent. Your alternate hypothesis, or your H sub 1, that's going to state that the data sets are not independent. So for example, the gender and exercise, my null hypothesis would be gender and exercise are independent. The alternate hypothesis, they are not independent. And I know that's kind of silly to write those out, but that's the way they want you to do it. Now, we're not going to say that they're dependent partly because the test is not concluding whether something is dependent or not. It's just telling us whether they're independent or not independent. So they might be dependent on something, just not necessarily each other. So it says it's kind of like a jury telling if someone is guilty or not guilty. You don't say innocent, you just can't say for sure that they're not guilty. Or we can only say for sure that they're not guilty. To figure out whether our null or alternate hypothesis is correct, we're going to compare our chi-squared calculated, this is what's going to give us in the calculator, to the given critical value, or, and this should say or. We don't have to do both, we can do one or the other. We can compare our p-value to whatever that given significance level is. And you'll always be given one. And like I said, it'll either be 10%, 5%, or 1%. So to perform this test, what we're going to do is we're going to write out our hypotheses. We're going to calculate the chi-squared on our graphing calculator. And I'll show you how to do that in a minute. But you're going to go to Stat and Tests and chi-squared test. We will determine the p-value on the graphing calculator. Or the calculator, or the test, will give us the critical value. And then we'll compare either our p-value to the significance level that is given to us. If the p-value is less than, we're going to reject the null hypothesis. If the p-value is more than, we're not going to reject the null hypothesis. So think of it as if p is low, reject. P is a probability, so that would make sense. If your probability is low, then you're not going to accept that. If you're doing your chi-squared calculated, okay, so again, you will be given the critical value. You're going to compare it to that critical value. If it's less than the critical value, then you do not reject. If it's greater than, then you do reject. So in this case, think of if chi is high, reject. So it rhymes. Chi and high, that's actually bad. P is low, that is actually bad. So kind of remember that the two kind of clever statements there, both are about it being bad. Okay. So for our first example, here we have a set of data, and I'm going to kind of walk you through how you're going to do this in the calculator. Now, you have a handout about how to perform the chi-squared. Okay, it looks like this. So I'm just going to kind of walk through those steps with this particular example here. So we have a real estate developer that's conducting a survey, asked 100 people who live in the city and 100 people who live in the suburbs if they preferred bicycling, driving, walking, or taking public transportation. I think I'm missing some commas in there, sorry. And the results are shown in the table below. So here are 100 city people, our 100 suburbs, and so on. So we're going to look at this test actually conducted at 3 different significance levels. That really doesn't require any more work. We're just going to have to give 3 different conclusions. We're going to start off by writing the null and alternate hypothesis. Sometimes on the exam they may only ask you to write one, but you should be able to write either one of them. We're going to use our calculator to define the p-value for this test. and we're going to determine whether that null hypothesis is justified for those three different significance levels. So stating the null hypothesis, so the null hypothesis is always going to be independent. So we're going to say that whether people live in the suburbs, in the city or the suburbs, is independent of their choice of getting to work. So you don't have to specifically say city or suburbs. You could say where people live is independent of their choice of getting to work. That would be sufficient. So your alternate hypothesis is going to be that it is not independent of their choice of getting to work. Okay. Now, to find the actual p-value, whenever it says to write down a value, like it says here, that's something that should be pretty easy, or something that you should not need to show a lot of work for. So to do this, we're actually going to have to put this data into our calculator, and we're going to put it in a place we haven't done before, and that's going to be under matrices. Okay, so on the calculator here, this is going to be the first set of steps on your paper. It says first enter your contingency table as matrix A. If your table has a row or column total, do not include those. I don't have any totals on here. You will see on some of the tables in your book at some point, you'll see a total for the amount of city and suburbs, a total for the amount of bicycles, the driving, the walking, etc. We don't want to include that in our matrix here. So to get to our matrices, we're going to hit second in the x to the -1 power. You can see it lit up there on the calculator. And I want to edit. I'm actually going to make a matrix. Now you're going to put in the dimensions of your matrix. So we're looking for the actual numbers. So in my table here, I have 4 rows of data. That's for bicycle, drive, walk, and public transportation. So rows always go first. And then I have 2 columns of data. That's my city and my suburbs. Now when you arrow down here, you can see that that matrix actually looks the same as it does on your paper. So you know that you've done your dimensions in the right order. It is always rows, columns. So if you think RC Cola, that could be an easy way of remembering it. Okay, so now you can just type your numbers in. You type it in. If you hit enter, it's going to go across. If you'd rather not go across, you can arrow to go down. Honestly, I would kind of like to put it my whole first column in first. And of course, just like anything you put in the calculator, you want to double check that you've put it in here correctly. Okay, so I'm double checking here just to make sure. Okay, and everything looks good. All right, so we've done go to matrix, we've done go to edit and choose matrix A. We changed the size of our matrix. We entered the numbers from our contingency table. Okay, so we're through the first set of steps there. Okay, now we're going to get out of here. So we're going to hit second in the mode button to quit. And now I'm going to actually perform my test. So we're going to go to stats. And we've been on this menu before, but we've never gone to tests. Makes sense because I'm doing a chi-squared test that this is where I would go. I need to go to the second screen here, and I want to go to a chi-squared test. Now, I don't know what this one is here. We're not doing that one. We're just doing the regular chi-squared test. So we're going to hit enter. Okay. And you don't want to change anything on this menu here. So I put my numbers that I observed, the numbers that were given to me in my table, in for matrix A. The calculator is going to put some stuff here in matrix B for me. This is not going to matter, and we're going to go to calculate. So don't touch anything on the screen, just always go down to calculate and hit enter. Okay, and then that's information that I'm going to want to jot down. So we'll use our 3 sig figs. Our p-value is going to be the 0.532. The chi-squared value, I'm not going to do anything with right now. That's going to be whenever I'm given my critical values. And then we'll use that one. The degrees of freedom, I could have figured that out on my own. That would have been 4 minus 1, 3, times 2 minus 1, 1, 3 times 1 is 3. So that verifies that number there. So I'm going to take this value and I'm going to go back to my notes here. Okay, so write down the p-value, just that value that was there on your calculator screen, 3 sig figs, 0.532. Now, comment on your results. This is where we do part C, determine whether the hypothesis is justified for those 3 different significance levels. Remember, if they give it to you as percents, you need to think of them as decimals. So, remember our little saying, pi, or the p, if p is low, we're going to reject. P being low, p is a probability, it's bad for it to be low. So comparing these numbers here then, the p-value In this case, p-value is greater than 0.01, so that's good. We're going to fail to reject that null hypothesis. So there is significant evidence to, sufficient evidence to conclude that where people live in the city or suburbs is independent of their choice of getting to work. Okay, now come down here. Also is going to be greater than, so same thing, we fail to reject because it's low. Hold on here. I'm sorry, our P is not low, our P is high on both of these, sorry. This P is high, this P is high, so we fail to reject. So we accept, essentially. A lot of times, instead of saying accept, though, they want you to say fail to reject. I can't really give you a reason why, but essentially it's the same thing as accepting. Now for the last one, 0.532 is greater than 0.1. So for all three of these, we're rejecting or failing to reject that null hypothesis. If the p-value is lower than these things here, again, it's bad to be low, then we will reject that null hypothesis and we will accept the alternate hypothesis instead. Okay. Sorry about messing up the wording there. Okay. Now, another example. Okay, so example 2, we have 3 different games here, males and females. We're talking about billiards, snooker, which is some type of a pool game, and darts. And we've got the number of club members for each gender that choose each game. And we're going to see if gender has something to do with the games that they're playing. Just like before, we're going to do this at 3 different significance levels. And we're going to use that p-value again. Okay. I stopped the video just for a second because I just wanted to verify that this first section in your book doesn't do anything with the critical values and the chi-squared. That's actually in the next section. So we're still just dealing with the p-value on these. So we're going to go to the calculator and we're going to put this data in. Notice that we have a total column here and we have a total row right here. So we don't want to put those in when we put our table in. So this table actually, it looks like it has 4 columns, but it really only has 3. And it looks like it has 3 rows, but it actually only has 2. So we're going to need a 2 by 3 when we go to the calculator. Okay, so I'm going to go back to my matrix menu. And we're going to edit matrix A. Okay, we're going to change the size. So let me get back to my paper here. This one is going to be 2 rows. And it's going to be 3 columns. Now, I did carry over some of the numbers from the last example. That's okay. You can just type over top of them. There is a way to delete those numbers, but it's really more trouble than it's worth. It's just as easy just to go ahead and type over top of them. Okay, so there we are. And we're going to get out of here. We put our data in. Now we're going to perform our test. So we go to Stat. And we're going to go over to Test. And we need to go on the second screen. And we're going to go to the letter C. So we hit Enter. And again, don't change anything on this. So we're just going to go down to Calculate. Okay, so again, that chi-squared value, we'll use that later on. Here's my p-value. That's kind of a low p-value, so that may not be so good for this situation. My degrees of freedom is 2. Again, that came from taking 1 minus my row times 1 minus my column, so 1 times 2 gives me 2. Okay, so I'm going to write that value down, the p-value down to 3 decimal places, or I'm sorry, 3 sig figs. So this leading 0 doesn't count as one of my significant figures, so 0.0203. Forgot to go over, sorry, my hypotheses here. My null hypothesis would be that choice of game and gender are independent. My alternate would be that choice of game and gender are not independent. Okay, again, we found our p-value. Okay, and then now we're going to compare to our 3 significance levels. So starting with 0.01, my probability is greater than 0.01. So again, P is low. That's going to be bad. That's going to be reject. So because my P is greater than, we fail to reject the null hypothesis. So we say that there is significant evidence to conclude that the preference of game and gender is independent. Okay, now we go to 0.05 significance level. In this case, 0.0203, my p-value that I calculated, is not greater than 0.05. I kind of put a greater than symbol there with a line through it so we would know we're trying to see if it's greater than. This one actually is not. So in this case, we reject our null hypothesis. So that says that there is sufficient evidence to conclude that the preference of game and gender are not independent. So they are in some way related. Okay. And then finally, preparing one more p-value there to a significance level that is not greater than. So again, we reject that null hypothesis. There is sufficient evidence to conclude the preference of game and gender are not independent. So again, that would mean that they are related. When we say that they are independent, independent means that they are not related. Okay. So it's actually pretty easy. The understanding it is, is a little bit harder, but most of this is just kind of typing the numbers in the calculator. Tomorrow we will do a little bit of arithmetic to find out some of the stuff that's in the calculator. Just to show you a little bit here, remember I said when we go to our screen, let me just show you again here real quick. When we go to this screen here and we go to our chi-squared test, I said don't change any of the stuff. Well, actually, we type numbers in for A. The calculator puts things in for B. So just to show you here what happens, if you go to matrix, and now you look right here, I don't know if you noticed before, but before this one had a different size. I didn't do anything to it, but now it happens to be the same size as A. All these numbers here, the calculator put in here, and they were all computed from the numbers that I put in for matrix A. So tomorrow we will, or in the next section, we will actually look at where these numbers come from, because you are going to have to be able to compute those. Not for an entire table, but you are going to have to be able to compute those. Okay. Let me know if you've got any questions. You'll be doing all of section 12.4 in your book. I think it's only 4 questions, but just like this, they all ask you to do all 3 significance levels there.